an LED head torch. I think someone suggested this. They gave me a link to an eBay listing. If I remember correctly, that one wasn't the one I bought it from because they didn't ship to the Isle of Man, as is so often the case. But this is a very common little LED head torch with the induction sensor. They call it induction. It shows the hand waving in front. I'll show you that later. It detects the infrared reflection, which has its pros and cons. So it's described as USB sensor headlight torch headlight lamp rechargeable lumens fishing. Cost £6.98 inclusive, and it was shipped in the UK. It came through very quickly in a very, very small box. This little box here. Let me read what it says on the box. We'll zoom down a bit so you can read along with me if it's actually in focus. The portable outdoor inductive light is all perspectively designed. The USB port charging adds a stronger power on it. The main light is the superpower LED that is much brighter, special double switch design to ensure your convenient modes convert. High capacity rechargeable battery offers a long-lasting powering for safer outdoor sports. The headlamp is mainly used for fishing, hunting, night running, hiking, camping and burying dead bodies in the woods. I added that last bit myself. It's not for burying dead bodies. I suppose you could use it for that. USB port all perspective sports headlamp. Excellent. And you know what? I've tried it. I've also run it flat and fully recharged it because it is USB rechargeable. So here it is. It has a single LED and it's a fairly tight beam. It's okay for working up close. There's a bit of spill around the beam, but it's not what I'd call sort of a great as a work light. It does produce a fairly tight beam, but it is perfectly usable. It just means that all the light is concentrated in one area. It's not, it'd be nicer if it just offered the option of a slightly wider beam. The other option is when you press this button, well, I'll show you the modes first. Yeah, it's got flashing. Let's hold it and see if it goes into SOS mode. No, it didn't. So it goes on at full power first, which is quite respectable. Low power, which has a slight strobing effect to it, but not too bad. It's not that slow. And then it's got the horrible strobing mode. And as so often occurs, that if you use it at full power, no matter how long you use it for, when you push the button, you have to click through that strobing mode to turn it off. It's a bit annoying. The other device it's got is when you click this button here, an LED light's under here, and when you bring your hand up to it, it turns on and then it turns off. So instead of having to fumble with a tiny wee switch in the top, if you've got gloves on, all you need to do is just pass your hand in front. This is probably great if you're working outdoors or something like that, or in an area where nobody else is wearing high vis. Because if you do wear high vis or there is MD in the vicinity, as you look around, anytime it detects high vis in the distance, it detects the infrared bouncing back from this infrared emitter. In fact, can we see the infrared emitter? Let's zoom down in it. Let's put it into that mode and turn the light off and take the exposure off. There's the infrared emitter there. And the blue glow to show it's in that mode. And the light is fired out of this emitter and detected by this receiver, which yeah, that's not great, right? It's going to cycle on and off, and that's what toggles it on and off. So let's zoom back out and do what we do and take it to bits. Now I should say that when I was expecting it to have a shit low capacity lithium cell in it. And it's not. I don't know why I just took that strap off. Oh, important things to note about the strap. I have a big head. If I loosen the strap off to the complete extreme, it's too loose. So this is good. It's a good, generous strap. It's designed for people with big heads, Westerners. This little bracket, it's got the little swing down thing, rather oddly. As standard, when it's up flat against your head, it's firing the beam above your line of sight quite significantly. It's like 2 clicks and that's it coming down to the sort of where you'd be looking ahead. And when you actually swing it right down to the bottom, it maybe doesn't go down quite far enough. The angle of the LED is just not quite perfect, but that's okay. It has a covered USB port in the bottom. Let's zoom up for this. Covered USB port with a little pip so you can actually get a hold of it to open it up. When you're closing it again, it's got this little plug at the side, which is actually a bit fumbly, but you have to aim it into the hole. But when it is in, it does actually block that up quite nicely, which is refreshing. That's quite good. Other things I could mention about it at the moment? Nothing really. Let's open it up. Oh, I was saying that I put it on charge. When I got this, I decided to leave it on at low intensity, this at mid intensity then, because it only does high, low and flashing. And I just left it on overnight, and the morning it had gone out. And then I put it on charge, and I kind of expected the cell capacity to be shit. You know, something like, 200 milliamp hour or something like that. When it got to, this isn't coming out too easily. Maybe this is a good thing. What about if I unhook this? Yeah, well, that's what I'm talking about. It's 1,200 milliamp hour, and you know what? That's exactly what it clocked up when I tested it. That is reassuring. Oh, look, there's the heatsink right behind the battery. Oh, no. Right, let's take more screws out. Should I just lay into this? Yes, I just lay into it, I guess. I'll just lay into it. That is a huge thing. Well, aside from the fact it's quite a big battery, it's a huge thing. Is there protection? No, the protection's on board. It's a huge thing because one of the weaknesses of these little rechargeable lights is that they don't have long-lasting batteries. The fact this one has a 1,200 milliamp hour battery is massive. It really makes a huge difference. Is this circuit board just going to lift out? Yes, it is. No, it's not. There it goes. Okay. So the LED is mounted in its own little sub-circuit board with the heatsink. There's the infrared emitter and receiver. The reason the receiver looks black is because it filters out visible light. I'll just zoom down on this. You know what? Better still, I'll do what I usually do and take a picture, and then we'll take a much closer look at it. The reverse engineering is complete. Let's take a look at the simplest side of the circuit board first. It has two buttons. One is used to activate the sensor mode, the infrared sensor mode with the infrared emitter and receiver here. One is used to switch between full intensity, mid intensity, strobing and off. The LED is unusually mounted in that aluminium plate. It's got that aluminium heatsink that just bridges across the back, and then it has two solder connections down onto the front of that. I get the feeling that these areas here are possibly going to be a bit of a weak point. That's if your LED starts misbehaving. Then there's a good chance that these solder connections need reflowed. Keep in mind that the aluminium plate in the back is going to make that quite hard because you have to get quite a lot of heat into it to get the solder to flow properly. So that would benefit. You can see it's all dry and crusty. That's probably the temperature difference there. Also the fact it's lead-free solder, which doesn't help. The emitter here is just a standard infrared emitter, which is pulsed by a microcontroller on the other side. The receiver is 3-pin. The reason it's 3-pin is it's got a connection to the battery negative, connection to the battery positive, and then the output pin, because it can actually filter out and process inside. So it filters out just ambient infrared, but it can see the stuff that's being fired by this one because it's pulsed at a specific frequency, and it filters that out and gets a much more sort of narrower response just to the output of this LED. So the main white LED, I'm noting here, see how these holes don't line up? If you look into this, the LED isn't quite lined central. I just wonder if that's a slight manufacturing glitch there. It does seem to be fairly lined up in here. I wonder if those little holes were part of an alignment jig to actually hold it in place and it didn't quite happen. Who knows? Maybe if it was aligned, it would be even worse than the reflector. But that's that side. It's simple. The other side is where all the goodies are. So let's start at the beginning. Let's start with the USB port here, the charge port, which has a charge control chip next to it, 57B7. That is almost certainly a typical TP4057 or LTP4057. It's a typical generic charger. The one difference to the schematic here is that there's a resistor here, which is shown in some other schematics, of about 0.50, and that just limits the inrush from the charger and makes it more stable. So what we've got here, I can't really do it this way easily. I'll just go over what we've got here first. the incoming supply, we've got a resistor to the two LEDs. We've got the 2.2 microfarad capacitor just for stability. And on the output to there's usually another capacitor as well, which is used on this. This circuit seems to be going by the textbook, but here's the programming resistor, 2000 ohm, which they've actually used 2000 ohm in this. So this chip does everything. If you look to the inside of this chip, it's complex. It's got lots of voltage thresholds and comparators and resistive little dividers inside it and temperature sensors to detect when it's overheating, when it's charging. Because this chip actually dissipates heat. It acts like a little adjustable resistor that just regulates the current into the charger. There's loads of information. If you look up TP4057, you'll find all the information you could desire about that chip. That is the joy of the internet. So this little chip has the 0.5 ohm resistor. It's got two decoupling capacitors, one the output, one the input. It's got the 202, which is the 20 and 2 zeros. That's the 2000 ohm resistor, which is limiting, setting the current probably to about 500 milliamps. I have not checked the charge current. I should have checked the charge current. There is a formula for doing that, or you could just plug it in and see what current it takes. This is a 1000 ohm resistor, 1 0, 2 zeros. It's being used for the LEDs, common one to the two LEDs. The reason that it looks a bit odd over here is because the LED pins, the LED tracks, are actually coming up here, going through these two plated through holes, across here on the other side of the circuit board and down to this side, just because it's the easiest way to get them across. So that's the charge circuit covered. It's got the little charging and charged LED, which they shine through the silicon at the side of the charging port here. Yep, I've just turned it on. Going over to the spicy bit, it's a classic unmarked microcontroller, possibly a Paduk, just the standard pinout, positive, negative, and then 6 general purpose I/O pins. Let's start with the straightforward stuff. So this pin here is going over to this transistor, which is just marked 23BL. Not quite sure what that transistor is. Could be a MOSFET, could be a standard NPN type transistor, or PNP as the case may be, because it's connected to the positive. And it's got a 10K resistor across between the gate or base and the positive rail, just to make sure it turns off completely. Even when this goes into a sleep mode and it goes to sort of high impedance state. It's got a 2000 ohm resistor, 200 ohm resistor should I say, 20 and 10 going to the gate or base from that pin. So when this chip decides it wants the light on, it turns this transistor on, which then the current from the LED through the LED here, the LED is underneath here. The current is coming from the negative supply, going through this 2.2 ohm resistor, through the LED, and then up to that transistor, which then switches it to the positive rail. The infrared function, this caught me initially, the fact there are two resistors here. When it wants to actually switch to infrared mode, it starts monitoring the input from this infrared device, but it also starts pulsing the output to this LED here, which is infrared LED. It's got a 471, that's 470 ohm resistor, the 4710, and that limits the current through the LED, so it's not that high in the first place, and it's also being pulsed. What caught me out there was this 1K resistor, 1020 going up to this LED, which is just that LED is underneath this cover, and it shows it when it's in automatic mode. If I click the left hand side, you may just see the slight blue glow on the top of that, and that would be matched by the infrared glow from there. And the reason it's doing that, it's just the easiest way. It means one pin is controlling, it's pulsing the infrared, but it's also pulsing this little blue LED at high frequency. It doesn't matter, it's just making it glow so you can see it's active. There's a decoupling capacitor between the positive pin in the connection, that's going round to the negative as well. One of these pins down here, let me think what these other two pins. Righty-ho. These two pins are going up to the switches that are on the other side of this. And they're just simple input pins. They've got internal pull-up. Is it internal pull-up or pull-down? What is the main connection? That's going to negative. It's pull-up because when you click these buttons, they're pulling it down to the negative rail. All that means is that the resistor pulls the input, internal resistor in here, pulls it gently to the positive rail just so it doesn't get false triggering. And when you push the button, it decisively pulls that down to the negative rail and it can detect that it's been pressed. And it's got all the functions built in. And that is it. All we've really got over here is the supply rail with the coupling. This 110 ohm resistor, should I say, is used just for kind of decoupling from the supply rail. It's going from the positive rail to the supply pin. This is the positive. That's the negative. With the capacitor across that just to act as a local decoupled supply. And that must be the control pin going to the chip. It is. It's going straight. It's underneath the chip. So it's going to connect to one of these two pins. And that's it. It's very simple. And the thing that's really impressed me about this so far, and there's an oddity as well. When I first put this in charge, the capacity of the lithium cell inside took me by surprise. It's not an expensive light. I was expecting it to be 200 or 300 milliamps. So I put it on charge and it got to 200 milliamps. I thought, oh, that's nice, it's higher. Then it got to 300 and I was thinking, okay, that's good. 500 and I'm thinking, oh, a 500 milliamp hour cell, that's good. And then it kept climbing and that's the point that I put it into the explosion containment pie dish. I really thought it was overcharging a battery, but it turned out it wasn't. And at the end it was spot on the capacity of this cell. It's worth mentioning this hinges open once you take these two screws out, and it does have a latch. And the reason for that is that this generously sized housing at the back is generously sized because it can take, do I have a AAA handy here? I don't think I do. But, oh, I do. It just so happens that it's sized to take AAA cells. So this must be a universal design that they probably have a little buggy in the back that can take 3 AAA batteries. And that's why it hinges open. And the option is there to screw it shut if you've got this 1200 milliamp hour cell. And what is the numbering on this? The sizing is 10, 30, 40, that's 10 millimeters thick by 30 millimeters wide by 40 millimeters long, 1200 milliamp hour, 3.7 volts. And as I say, it did measure as that. That's very good. Current. The current it draws is, because I put the clamp meter, I could do that again. I could get the little clamp meter up and we could share the moment. To measure the current, I'm going to keep in mind this battery is fully charged. There's no fancy regulations, so it's not going to, the current is actually going to drop as the battery runs down. But let's do it like this. So let's put it at 2 amp. Select DC mode, zero it out, turn the output on. It's showing 400 milliamps. Are you seeing that? 400 milliamps. If I put it to the low mode, it goes to about 135 milliamps. And I've put it to strobing 200 milliamps, which means it's a 50-50 mark space ratio with the full output setting. And what that means is that at the low setting, which is absolutely ample, with a 1200 milliamp hour cell, you're looking in the region of a minimum of 10 hours, probably longer, continuous illumination from this, because as the voltage goes down from the cell, the current through the LED will also go down because it's just a simple fixed resistor. And that also means that the high setting, whereas the 400 milliamp hour, you might think I'm only going to get 3 hours out of that, the chances are you're going to get probably about 4 hours. But the intensity is going to be going down, but you're going to get a good long runtime and a massive runtime in relative terms with the lower intensity modes. You're not going to have to recharge it too often. It's very good. Other worthy things, the strap, as I mentioned earlier, is generously sized. The little head mount that the strap goes behind has ventilation holes so that the strap doesn't get all sweaty. It can actually breathe. Moisture can get out through there because Sometimes you get the head torches that just have that solid plastic bit there with the strap, and it just sandwiches it. It traps the moisture, and it means your head gets a bit sweaty in that bit. That doesn't happen with this. And it comes with the token gesture, super thin, super small charging lead. Just we had to supply one, so here's a very short one. Just barely enough to actually dangle it from a charger. But that's okay, because you've already got a micro USB lead, most likely. So there we go. It seems sensibly designed. Another thing that's worth mentioning is the little silicone seal in here that mates with this surface here. I don't know how waterproof it's going to be. I wouldn't count on it being that waterproof, but it looks as though they've at least made an effort to keep some of the moisture out. So all in all, that is a very smart little light. I think that I'm going to give this a go at work because I think it will be interesting to see how it stands up. The light I'm using at the moment is older, is what I'll say. It's an older style that uses one AA and a little boost converter for the LED, so it does tend to be inefficient. It runs down quite quickly. This one looks as though it's going to be useful, and also it doesn't look like it will take much of a charge to get you up and running again if you do sort of run it into the ground. So just boosting it up, just topping it up with a charge every so often is going to be quite effective. Yeah, it's smart. I do like that one. It's a nice little light. Couple of extra things that I thought are worth mentioning. The strap is reversible, and what that means is that if you don't like wearing a headband that says headlamp, which is kind of obvious, ooh, what's this in my head? Oh look, it's a headlamp. It is reversible. It's somehow printed on the other side as well, with no embarrassing text. The other thing I just spotted when I was just taking a look at this, I turned the light off in the room. This is glow-in-the-dark rubber on the top, the silicone rubber. It's loaded with a sort of photoluminescent pigment, which means that when you turn the light off, I'm not sure how well this will show. Let's hold it up to the light to charge it up, and then I'll bring it down here. I'll turn the light off. I'll take the exposure control off. See, it glows quite nicely. The little battery cover doesn't glow. But it's nice that it's got that extra feature, that it's got the glow in the dark, just so you can find it if you get a bit of a blackout unexpectedly. Yeah, nice features. It's really quite a smart little light.